everybody. It is Mike Levin on Sunday, March 13th, 2022. 3 months in, and I can finally get my timestamps, my audio timestamps correct. And I'm on I-95 North on the split where you can choose between a truck and cars versus a cars-only route. The other day I took the truck and cars, which is what I normally do because it's easier to pick up the George Washington Bridge exit. Although I don't take the bridge, I am already on the Jersey side. So I shoot out west from about that point. But the traffic and the construction work and the lanes that were closed and the exits that were closed the other day after picking my kid up for the weekend were unbelievable. I ended up taking a completely different route than I normally took because I had to keep adapting on the fly. I don't know what I would have done without GPS. It goes to demonstrate how much we truly depend on our Uncle Google. So, it was telling me take this exit and go around that clover leaf, and I was following its instructions, and it somehow took me some zigzagging route to get back to my traditional route, but quite a few miles west by some route I would have never in a million years thought to take. And the interface of Google Maps itself is gradually improving. It's continuous, deployment, continuous integration. Well, anyway, the app continuously updates underneath of you, getting better and better features. And I think maybe even without updating the app itself, which does happen, the app gets updated, but I think then the way the data is formatted and presented within the app can gradually get better without full app upgrades. But at any rate, Google Maps has been looking pretty good recently and has clearly been getting smarter. And what else? I don't know. It's a thing to be thankful for. That plus car, and I'm thankful for Jeep Wranglers. I try not to be a Jeep snob, but then, you announce you're about to do it, right? So we all project. It feels good to have a car that you don't have to have in the shop very often for very much. These things are built to a spec that, is for off-roading, for, fairly abusive use. So all the parts are really built to endure, like a rugged laptop. They used to have these, I think, Panasonic rugged books that were very appealing, and they were supposed to be able to take a beating. Well, things are built to a tougher specification sometimes, and Jeeps are like that. So it feels good to, know you're not going to just have it into the shop for silly nonsense. You get your oil changed regularly, you get your scheduled maintenance tune-ups, and it'll just serve you well. I had like very few miles on it. I was like 15,000 miles, 20,000 miles, 25,000 miles with like New York City driving. I owned this Wrangler in Manhattan. Yeah, I kept this in it seems almost like a dream now. It was a number of years, but I was living on Manhattan. After that, I lived on Staten Island for a couple of years. But for a good long stretch, I was a car owner on Manhattan and owned an apartment too. The very northern tip of Manhattan. They called it upstate Manhattan. And it's a interesting little neighborhood up there. I'll tell my stories sometimes. Do I have stories? Anyway, once I moved out into the Poconos, the mountains of the I guess the lower foothills of the Adirondacks. There's a very large mountain range, the Adirondacks, which the Poconos is not really a part of, but I think it's sort of adjunct to it or something. And so I live at some of where just the ski mountain resorts can begin, because the mountains are just big enough, but only barely at that. And so Shawnee Mountain is the mountain that I sort of learned to ski growing up. It's the mountain that my parents took me to growing up, and I had an interesting experience. I was over at Shawnee Mountain, I rented some equipment, but I had to make a quick driving trip, and they were like, oh, you can leave your equipment here, that's what we're here for. And I'm like, oh wow, I didn't realize you can just leave the rental equipment and they'll keep an eye on it for you, I guess. I was very skeptical, but I took their word for it. And I was like, yeah, I used to come here like 40 years ago. And they're like, that's funny because we're only 37 years old. And I've meant to Google it, but I do actually kind of recall going to Shawnee a few times when it was a rickety little ski hill with just a wooden T-bar system to bring you up these mountains. And it was before a big renovation and new owners and then turning it into more of a, competitive skiing destination, competitive with Camelback Mountain, which is nearby, to take off a little bit of the overflow. But, and these were not young guys who were saying this to me. So I think these are people who might have been in with, quote, the new owners. But I believe I might remember Shawnee Mountain, and I got to do my research from before these new owners took over 37 years ago and, put in some good ski lift equipment and stuff. But that's where I learned to ski when it wasn't in the backyard of my house at 14 Copper Beach Drive where I grew up. It's no longer my house. Some cool people have it now who used to own a chain of cookie stores in my neighborhoods growing up, and they bought my house, and my next door neighbor runs the local candy shop that I used to go to growing up. There's this real theme of sweet, tasty treats apparently in the house I grew up in and the houses surrounding it. There was the Candy Man, I remember, who everyone used to try to go to multiple times on Halloween. And my mailman who taught me the million view removable thumb trick. And their family, the Sucros, and my friend Ricky Sucro, growing up, a friend from the neighborhood, more so than an ongoing friend, but his sister, Stacy, never fell out of touch and got back in touch with us through through YouTube, when I posted his removable thumb trick. She saw the video, read the related article, the connected article to it that talks about how I learned that growing up, and asked whether it was okay for her to bring it up with her dad when he was around. And I was like, of course. And he was so touched that I remembered him and called him out specifically. And then he got Alzheimer's and passed away. And it was very sad, but I was happy to be back in touch with Stacy and her family. And it's interesting to have connections with people who you knew growing up, and these funny threads that run through things where you end up touching, a million views doesn't mean a million people, but my mailman growing up, when I was probably 6 or 7 years old, taught me the removable finger trick. You use your thumb to do it. It's not the removable thumb trick. They call it that, but you're really removing your pointer finger, your index finger, but you're using your thumb bent over as a false extension of your index finger to pull the trick off. So that became my second million view video, the first being the Raspberry Pi unboxing, the second being that trick. And now I just passed 10,000 subscribers. Thank you very much. And the YouTube algorithm seems to be kicking in and rewarding me. I've gone from about, 400 viewers in a 28 day period to like 4,000 or something. So there's a factor of 10 increase in audience going on in my YouTube audience, and you're tuning in to me for something. And I'm gonna repeat my mantra: Linux, Python, Vim, and Git. That's all you need, plus Jupyter Notebook to get started, Jupyter Lab in particular. And I'm in the field of search engine optimization, and Jupyter Lab is the secret weapon of SEO. Jupyter Lab plus Python, plus a few other things that are coming together in beautiful, syzygy, union, alignment, the intersection of four spheres of a Venn diagram, I would call it. So Jupyter Lab being standalone as a desktop Electron app, very nice, very nice. I don't think it supports the extensions system yet, so it's shut out of a little bit of that world. However, and virtual ENVs are pretty weird, but it's okay. You're updating it so much, which seems to nuke your virtual ENV so often, you just get used to reinstalling your application requirements. It gets you in the habit of using a dependency manager. But Jupyter Lab standalone application, plus Python itself, the maturation of the Python programming language, plus the Pandas library, which is generally pre-installed with Jupyter, which still seems to have a lot of Anaconda dependencies. I hope there's not licensing issues there. I'm on standalone Jupyter in no small part because Anaconda changed their terms of service, and I do not want to agree to Anaconda's terms of service. I don't like it, and I think I still should be able to use Jupyter notebooks. So I'm switching to the standalone version of Jupyter Lab so I don't have to install Anaconda, yet I see some sort of Conda engine still underneath of it. I'm a little disappointed in that, and the install size is still like 500 megabytes. I'm a little bit disappointed in that. But besides those nitpicking details, very nice. So the Python language itself, I would count as one of those big spheres. So draw one big circle for Jupyter Labs standalone, one big circle for Python in general, one big circle for the Pandas library, and then, which for those who are not familiar with it, is basically ways to process tabular data, rows and columns. If it looks like an Excel spreadsheet, or it looks like a SQL table, well then it also looks like data that would live very nicely in a Pandas data frame, often represented by the letters DF. DF equals PD dot data frame in initial caps case, capital D, lowercase ata, capital F, lowercase rame, open parenthesis, and then any data shape that looks like a list of things that might make a good table. It can be a list of dictionaries, it can be a list of tuples, what have you. And the library's smart enough to figure out how to turn that into a properly column named grid of data. Whatever was in that list of dictionaries or list of tuples or list of lists is also now in a row and column addressable data frame with the columns labeled correctly if you started from a shape that had it, or you provided columns explicitly on the argument as columns equals some list. And it has to match. One of the most common errors in Pandas is when you're creating a data frame and you're giving it column names, and the number of column names you're giving it doesn't match the number of columns in your data frame. Very, very common error, and you have to look at how you're misaligning your attempt at stating the data frames. But if you're starting out with a list of dictionaries, you don't even have to give it column names. It just infers it from the dictionaries, or key value pairs. So the key is going to be the column label, not the key, but the name of the argument of the key value pairs, because they're key value pairs, but it's something equals something. So you look inside a Python dictionary, you'll see what I mean. It transforms perfectly well into column names. So Pandas is that third circle, and then the fourth circle I've been talking about on and off in my videos, but it is SQLite. P in the pool of tech. Once in, it ain't coming out until the pool is drained, You're talking Armageddon or something to drain the pool of tech. The pool of tech ain't being drained. Gradually, hardware will come out to replace old hardware. New hardware replaces old hardware. CPU bottlenecked architecture gradually gets replaced by neural net, machine learning friendly architecture. So, CPU space gets replaced by gray matter, because all that stuff is almost kind of equal in its ability to be configured into, custom pattern recognition things. Chips where almost in the hardware, it seems, get better at learning things because you're optimizing the connections between hardware processors, or little processors called neurons, that do simple calculations like measuring the intensity of input, which is not often, but it's looking at some of those might get replaced by analog computers. The resurgence of analog computers as neurons in a neural net, or at least the part of the neuron that handles sampling sensory input, because sampling sensory input on analog is analog. Needles carving grooves in vinyl and playing it back by a needle, rolling over those same grooves to reproduce the vibe, the energy sound waves, dude. So what you've got is tech will stay mostly the same, but things gradually drift. There will be underpinnings, mostly to get systems booted, that will never drift, because you need the methodologies of starting to read at a certain location in memory from the hardware and following its instructions blindly, because it's your boot sequence. You need to be able to take control of a booting piece of hardware at that level, or you don't own it. It owns you. It's a piece of hardware in your life, but it is owned and managed by some remote corporation. Your iPhones and your Androids in your pocket today, this phone I'm recording this video, are much like that. Now, it's much for the good of the world, because it is hard to keep hardware like this so awesome and still have its teethers cut. There is very little independent hardware that stays cool and leading edge. Normally, stuff that's staying cool and leading edge is tied into some update software repository and system management thing. I forget the acronyms for it, but one of the most popular operating systems in the world today is Minix. Not Unix, but a proprietary microkernel version of it, MINIX, based on Unix, but it's Minix. Created by Andrew Tannenbaum, I want to say, and he's like the bizarro Linus Torvalds. So Linus Torvalds made a Unix-like kernel in the form of Linux boot kernel, the stuff that breathes that moment of life, that Frankenstein moment of it's alive. A lot of low-level hardware stuff there in that Linux kernel. But he made a version, and Unix itself is a version from, say, the Berkeley lineage and the AT&T lineage. And I think they call that the mock kernel these days. And I think the iPhone is based on that. So the iPhone is in a Bell Labs tradition. Android is in a Linus Torvalds tradition. But every piece of Intel hardware out there for about the last 10 years is in the Minix tradition, because governing it all, the thing that controls that smart sleep state that your laptops seem to have, so they're always doing the right thing, is a little Unix-like system that you don't have any interaction with. You don't have any idea what it's doing, but it's managed by the vendor. It's vendor-managed hardware. And it's running a little full network stacked, talkable to, with its own addressable location, probably its own IEMI. I forget these exact acronyms, but globally unique identifiers of hardware, right? So there's something calling back to mama that you have no idea what's going on, and you just got to trust them. You got to trust the vendors, and you got to trust the vendors to not be hacked, and you got to trust that foreign nations aren't taking advantage of backdoors in these systems. I mean, it's like the definition of backdoors. So know that you all run Minix on every one of your Windows 10 and Windows 11 pieces of hardware out there, certainly all Intel-based stuff. I believe most AMD-based stuff now, too. They have their own version of it. Being on AMD doesn't make you safe. Now, perhaps being on Apple does. I'm not sure. They developed their own ARM-based hardware, and they did that dramatic break-off from Intel. I think somewhere after, I think it was Sandy Bridge or Ivy Bridge, something like that, some bridge. At which time this Intel management system was incorporated, and lots of complexity that Apple was not very happy about. So they're like, oh, the timing seems right for us to do our own thing. And we'll continue to pay our licensing probably to the ARM Corporation, what was once the Acorn Corporation that did either the BBC Micro or a competitor to it, kind of like the Commodore 64 of the UK. And they did a reduced instruction set, a RISC processor called ARM, or the Acorn, architecture, which has since evolved into what we know today as ARM, and all the various Cortexes and variations thereof that are licensed out to people who build stuff out of it, because ARM doesn't make hardware. They're not like Intel that casts the chips. Not that Intel does it much more themselves anymore either, right? It's all being farmed out to companies that have, I forget that company, but they're down to the 5 nanometer design, and there's only one company that makes the fab equipment for the 5 nanometer process, and they have like a world monopoly on it now. It's really amazing. And the tech that does it, with this drop of tin like being vaporized, and plasma and 3-dimensional stuff, it's all very impressive, and it gets stuff down to the 5 nanometer scale when making transistors, packing more transistors per square unit of measure than before, and topping out Moore's law, because traditional behavior of semiconductors can't be made much smaller than that. It's maximum smallness. So now the creativity gets into how to hook all that stuff up into more optimizable neural networks. I'll probably change the layout of the transistors, still pack it in at 5 nanometers, but stuff is going to be much more like gray matter substrate than discrete CPUs, right? So computing power will be measured in, surface area, square surface area, or maybe square volume if it's stacked at some maximum density with three-dimensional circuits and layering. So that's all in our future. That's all in our kind of present. It's just incremental improvements, and you layer into that inevitable free or nearly free energy, because fusion, the crossover of fusion, is, I believe now, it's not just 30 years away, it's going to happen. So a lot of interesting things coming down the pike, a lot of interesting things, and one must be prepared, and one must get rid of imposter syndrome. You cannot be an imposter. You need hard skills in this hard world. And what are those hard skills? Well, it's the intersection of those 4 circles. And I was talking about that 4th circle. What is it? It's SQLite. SQLite, through various APIs that can get you working really well quickly locally with your local resources, not depending on the cloud, for database-like things. I'm experimenting with it now. I got fairly familiar with the vendor nuanced implementation of SQL Server, Microsoft's SQL Server. Yes, indeed, I was a SQL Server user. So when the LAMP stack was all the rage, I was an active data object person, an active server page, active data object, and so that meant we were connecting to SQL Server or something like it to just iterate through database cursors and grab what we needed when and do some updates back. Just the basic database trick. And it's always the same trick over and over, but it was always the same trick on Windows with these high-end server products or Microsoft Office for access. And, all of this dialect-specific stuff that wasn't used by other people, top versus limit. It was just theta joins versus there's a bunch of dialect differences. And then there's the fact that writing SQL is a pain in the butt in the first place. So when I had a chance to say goodbye to SQL, I was like, goodbye SQL. Life without database, and if you have to use database, use KeyValue, because the optimization on hash lookups is so beyond, it's just, it's been one of the real hot spots of app optimization. So key value pair lookups can be against millions of records and be very quick. So you say, here's a key, give me the value back that's associated with it. And to scan across potentially millions of records is just instantaneously quick. So with that kind of power of key value pairs, you can build a lot of other things out of that, including the tabular stuff. So key value always comes first. And tabular implementations are very particular, are very vendor specific, it usually seems. You're learning some very peculiar and particular API, how to control, Microsoft Excel structures, how to do updates to a Google sheet, and rows and columns. So when you're looking for generic rows and columns, it doesn't take long before you discover Python Pandas, and then you're like, oh, Pandas provides an alternative to SQL. Not really. Pandas provides a convenient intermediary language between table systems, because your table systems are going to deal with persistence. Data frames are not persistence like any other data object in memory, like an integer or a a tuple. You lose power, the value is gone. It's not persistent. It's not written to a database or some storage media. So what you want to do is use a KeyValue API, a name value pair system. So you have the benefit of those fast lookups of key value pairs, and so that you don't have to deal with row and column details. You don't need data types, none of that stuff. It's just, for this key, here's a value, and you almost don't even care what data type that value is. You can just store it somewhere. You can put it into a place that's just made to store generic values hanging off of keys. A big bag of, values that have keys that unlock those values. That's a dictionary. Making a dictionary persistent with SQLite as your back end, as your optimized, compiled C piece to do the actual work, but the interface to SQLite is a Python dictionary, a DICT. So there's 3 data types in Python that do most of the work. They are tuples, dictionaries, and lists. They each have their own role to play. They have different behaviors. Lists can grow as long as you want, member-wise. If a list has 3 things inside of it and you say add 1 more, the list is fine with that. It's like, fine, I got 1 more in me now. With the list, if you say, the data types are different on each, this one's an MPEG file, this one's an integer value, and this one is an exe, blob. The list is like, okay, fine, I contain those 3 things. I'm just a bunch of references anyway. So they're dynamic in nature, and as thus, you can't really clone a list very easily. You can clone a list, but it inflates a lot in memory, and it's hard to do. You have to either use slice notation, which is a shortcut of doing it, which is what everyone does, or there's a copy method built into a lot of objects. You can invoke the copy method of an object to make an actual copy of things like lists. But no one really does that anymore. You just take a list and you put a couple of square brackets after the name of that list, and you put a colon between those square brackets. That is slice notation from beginning of list to end of list, and because you're taking a slice, it's a copy. That's a way to make a copy of a list with minimal keystrokes, with the least to look at. But it would take a very Python-oriented person to look at list name, square bracket, colon, close square bracket, to go, they're making a copy of that list. Well, this and more you will get to have come natural to you in Python, become part of your muscle memory, and last with you forever and ever. Amen. So that 4th circle is various APIs to SQLite. So I talk a lot about SqliteDict, using dictionaries as your API to SQLite, so you can deal with things as key value pairs. And that is a wonderful approach for the fast data capture. You're hitting an API, call after call after call, and you have to unload it just as fast as you can to some, preferably inexpensive and preferably local data store, so you get maximum performance after the data call. This is where so many people get tripped up on the web. They think, the web will just pay for this all, and yeah, you can get it to work that way, and yeah, you can just pick a service like Google BigQuery and just have that data get captured real fast at very little expense for long-term storage. But then you want to query it, cha-ching, 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 charge you. Just put it in local in SQLite. Query it as much as you want. SQLite is nice. Fast data capture, key value pair. Your key is going to be probably some string, And your value is going to be probably some blob, binary large object. In SQL parlance, if you're to look at the data types of the columns of the table that get created when you use the SqliteDict package to make dictionaries persistent. And after you do that, after you make your dictionary persistent, you need to turn around and transform that raw data capture, because it looks much like the exact API responses that came in. You store not the JSON of the API response, you store the entire response object in SQLite in key-value pairs. The value is a requests, or more frequently now for me, an HTTPX response object. The whole kit and caboodle. You can get the response headers out of it again, the response code, and a bunch of other goodies. Yet you can step through it one record at a time, one key at a time, iterating through all the contents of that SQLite table and transform it through usually some list comprehension looking thing into a Python's data frame friendly list of lists, list of tuples, list of dictionaries. Any of those three will do. List of tuples is preferable so long as you can feed the column names in cleanly. If you think you're going to have problems feeding the column names in, go with a list of dictionaries, because it will infer the column names from the dictionary labels. End of story? End of story. That was sudden. That completes a vision. Linux, Python, Vim, and Git. That's where you're working towards. That will make you obsolescence proof, disruption proof, obsolescence resistant. That's, I think, the word combination I've been going for mostly. You resist disruption and you're obsolescence proof. You well, anyway, you can reverse it. You see where I'm going with that. I don't think I want to finish that word puzzle. Linux, Python, Vim, and Git will make you always a valuable voice in the project. You will always have one viable way to get that thing done, according to some 80-20 rule. Certain packages will probably have to be added to customize Python into what it really needs to be, because it's not always what it needs to be, not with a quite formidable yet still surprisingly spotty standard library. The standard library does not have a numeric array data type. For that you need NumPy. NumPy used to be difficult to compile and install on your machine. It's not difficult to get on your machine anymore because of pre-compiled binaries for every conceivable piece of hardware, thanks to the Wheels system, where the Python packaging index can contain a pre-compiled binary for every popular targeted piece of hardware. Although the developer really has to provide that themselves on the upload, unless you're using some Git integration that does it post Git push. But most people are going to do some sort of local build process and then use maybe the twine package, pip install twine, and that lets you push things up into the Python packaging index with built packages built on your local machine. So you're at least going to have the member of the wheel that targets the same kind of hardware as you. But when you're talking about a popular package like NumPy, they're going to pre-build it for all the popular pieces of hardware that they have access to. The Apple ARM stuff is something of a wild card, because what does that mean? You have to have Apple hardware as a developer to have a compiled 64-bit ARM version in your wheel? Without excessively convoluted tricks, it's looking like the answer is yes. Yes, you need Apple hardware to create an Apple binary. So, I got off on some strange tangent there. Oh, you know, there's other ghost circles in there. I drew the 4 big circles that come together to make all of this magic possible. Jupyter Lab's standalone version, Python itself, the Pandas library, SqliteDict, but the pip wheel system is like a honorary 5th circle in that overlapping Venn diagram, making all kinds of wonderful things now possible. And yeah, my ears are popping from being up in the mountains now. That does rather complete the story. You know, the rest is details. By using a notebook in Jupyter Labs, you can pip install nbdev. I'm also doing this from the Linux side. In fact, the nbdev tools I'm really using are from the Linux side of my Windows machine. So I've heard it called Whistle lately, but you know, I'm running Whistle 2, and I have been for almost as long as it's been out. I was on Whistle 1, now I'm on Whistle 2, the Windows subsystem for Linux. And I use it daily as almost my primary thing on Windows. I'm on Windows hardware because it's really nice. An $800 Windows laptop with its touchscreen, svelte design, you know, top-notch build is a good value for the money. Incredible driver support on the Windows side. But now, you know, I use the Windows subsystem for Linux almost as my primary environment, except for when I'm in Jupyter Labs on, you know, on an Electron application, which is essentially a browser, a desktop browser app built out of the Chrome parts. So that's really, it's magical what's happening. It's hard to believe all these parts get wired together and it works. Jupyter Labs is a small miracle. So the parts that are going on there, just for anyone who hasn't like looked under the hood or just listened to all the, you know, different people talk on Talk Python to me, Michael Kennedy's Python podcast, to the people who made all these different parts, because there's a lot of parts. Jupyter Lab is built on a number of pieces. It's again the glue that brings things together. I talk about how Flask brings together Workzoid and a couple of other things to become the Flask micro framework. Well, Jupyter Labs standalone version is bringing together the Electron platform, which is the Chrome components from the Google Chrome browser, the Chromium free and open source project. Its parts, because it's free and open source, have been broken out and turned into an actual, you know, desktop application development environment, which some very popular apps have been built from, namely VS Code and Slack. There's a few other big ones out there, but those are the two that most people would know. And they're also, according to a fair number of people, the only quality Electron apps in the Microsoft Store. Everything else is poo-poo, according to people who have given me feedback. Nonetheless, it is still a very big game changer in the technology landscape, because, the full web stack can now be used to create standalone apps, and it's quite well proven. And Jupyter Labs standalone happens to be one of those, and people who are on it now are on the bleeding edge of some world-changing stuff, because making Python an excellent implementation of Python instantly accessible and friendly to people with one, Windows, Mac, or Linux desktop install, and now you have Python in a familiar web-like environment, and sprinkle in the magic of nbdev with pip install nbdev, and now you have the ability to create Python packages as extractions from your well-documented and well-tested notebook. So certain cells in your notebook get exported to a .py file. And when they get exported, there you also create documentation at the same time. And it's like an alternative to some of these, auto documentation. Sphinx is pretty big in the Python community. There's a Sphinx documentation database engine. The way they talk about it on these podcasts, you would think it's like the heir apparent to like Documentum and these massive document content management systems that used to exist almost pre-web in the 90s. They really tried to adapt these, open text systems and stuff to being the engine of the web, because it's so close to doing web type stuff. It seems like just a little push and you've got a web system, a web content management system. But it was overblown complexity, and the LAMP, the simple Linux, Apache, MySQL, PHP stack, won out over Documentum, OpenText, and their like. And so it was another case of it wasn't supposed to happen this way. The internet wasn't supposed to happen this way. It was supposed to be multics, ka-ching, ka-ching, ka-ching for every compute cycle. But no, Unix came along, then Linux came along, and then the LAMP stack came along, and the internet came along, then the web came along, and the Python came along, and ZeroMQ came along, and the full web stack came along, and Node.js is part of the full web stack, and JavaScript, of course, too. And all this weird technology, weird mix of stuff, which at first was very awkward, was very cumbersome, was very flaky and unreliable and slow and timing sensitive and fragile and error prone and prone to let errors slip through quietly, and all these things, and crashing, tending to crash, stack overflows and whatever. There were a lot of problems with tech in the early days, and there were particularly a lot of problems with gluing a lot of tech together and trying to make heterogeneous technology seamlessly work together elegantly, at a nice speed, without losing too much to ziggurats of virtualization. This virtual machine running on that virtual machine, running on that virtual machine. It's virtual machines all the way down. Reality, we're going to find out, is a lot like that. It's not a question of whether we are a simulation. It's the fact that we are one of the many simulations that exist in a hierarchical nested relationship that forms the computingness of all reality. How could it be otherwise? It's hard to imagine at this point, given my immersion in tech, my love for certain, parts of tech, aspects of tech, and coming to appreciate on how tech is made in the image of things we observe in nature. Certain imaginary things, truly imaginary, occasionally exist, but mostly not. Mostly things are related to things that exist very much in real life and are named as such. Registers and stuff like that. CPU cycles. Oh man, someone really doing bad driving maneuvers, but I'll just give them plenty of following distance. Okay. I guess I should be wrapping this one up. We're coming up on 50 minutes. Maybe I'll top it off at an hour tops. I guess a point that I'm trying to make, that I'm dancing around with all kinds of not right to the point language, is that tools are much better today, and they're working much better today. The Amiga's vision of inter-process communication has arrived now in the form of Python APIs built into software. Python APIs in Blender, Python APIs in FreeCAD, Python APIs in the browser itself. You might say, oh no, it's Puppeteer is, JavaScript APIs, but Playwright, Microsoft Playwright, Microsoft's port of the Puppeteer library has native Python API, so API control of the web browser natively, synchronous or asynchronous, not forced into asynchronous the way Puppeteer does. Okay, so I need to kick the tires of Playwright in Jupyter, especially standalone Jupyter now, because it wasn't working too well back last time I tried it, but I'm sure they're going to be pushing it forward. I am right in the bleeding edge. Okay, yeah, so that's the downside of all this. Many of the tools have matured right to the point of usability. However, in such things as standalone Jupyter, you're on the bleeding edge. Things may not always work as expected or as promised. Things might blow up in your face. You might lose keyboard shortcut input on Jupyter cells after a Control-R refresh. Gee, I guess I ought to submit that as a bug report, huh? So things will get fixed. Some things will get fixed. Some things will improve and other things will break. And you just have to roll with the punches. Roll with the punches. I talk about Charlie Brown landing on his back after attempting to kick the football that Lucy is holding. One of the eternal metaphors. One of the images that is really stuck from old-timey comics. I don't know how politically correct it is anymore about what it's saying about roles, but it is true. You must always expect to be Charlie Brown in that position. The ball will be pulled out from underneath of you. No matter how something is advertised and promised, the reality may be very different. You cannot live life scared. However, you must be prepared to land on your back every once in a while after making a good attempt at something. Land on your back, pick yourself up, dust yourself off, and try all over again. I probably really mangled that, but the ant who can move the rubber tree plant, right? So that's one of the little gifts that came to me through, Boomer sitcom, Laverne and Shirley. Oh, there's some comploids, I guess. Well, I'm always going to speed limit. I'm good. Think. Where are you at? Where are you at in your head? I love how the cop lights are like Knight Rider lights. Oh, my kid keeps saying, okay, boomer to me. Am I a boomer? I guess, maybe. I was born in 1970, right? So the kids of the generation who could have served in World War II. So even though you're not part of the crop that popped out 9 months after the GIs came back, you are still a child of that generation who could have been having kids into their 40s. So you're talking good 20 years after the war. If you go 25 years, see, 45, 65, 75. No, you don't even have to go 20. I guess I might be a boomer. 45, 55, 65. That's 20 years. Yeah, you do have to go 70. So 25 years. 25 years after the war, I was born. The same year as Unix was created, as I point out quite a lot, but I learned recently that the game of life, I forget his name, Chris Conway, perhaps? Jonathan Conway? I think Conaway. Something Conaway. I'm going to have to brush up on that. But the game of life, which if you search on Google, by the way, I highly recommend going to a web browser and search on Google for the game of life and watch what happens in your browser. There's a magic little spell cast at you. You don't even have to visit one of the sites that runs that simulation. But beautiful patterns emerge that have seemingly impossible complexity over time. And it's a humbling lesson about the apparent non-determinism of a deterministic universe. So a deterministic universe can present itself as apparently non-deterministic, and that's just with an algorithm running on a digital computer. Much less what's possible if you introduce systems that, you know, truly have turbulence and chaos in them, so that you can really roll the dice. Unpredictability. Is there true random? Can true random, does what presents itself as true random in quantum mechanics actually have some deeper underlying order? That's one of those great unanswered questions. All kinds of interrelated questions, but boy, I don't want to go too existential on this video, because I think I have a chance of wrapping it up cleanly at, yeah, just about at an hour. I'll wrap it up cleanly at an hour. How about that? I believe in Linux, Python, Vim, and Git, yet the four-circle diagram that is changing the world currently, in my view, is standalone Jupyter, Python in general, Pandas library for Python, and SQLite built into Python. Those four things. So the way you can get a Python execution context that is delightful. Jeremy Howard, Donald Knuth, literate programming environment that is delightful. You can embed documentation various ways, switching between Markdown and Pythonic techniques to put comments in, and, you know, other forms of documentation, good doc strings, things that auto-generate documentation, everything, assert tests. Things start to become very generic and beautiful, and yet still part of this fairly heavy-duty tech ensemblage of parts that is Jupyter Lab. And it replaces so many types of systems that I've attempted to do in the past. Your framework is Python. Your slightly modified, extended framework is, you know, Python with a few pip installs, or whatever data science stuff is dumped on there through a Jupyter install. You're going to have Pandas there. So Python with Pandas, and, you know, SQLite as part of it, and a couple other pip installed libraries. One that you're going to want is pip install SqliteDict. You want pip install SqliteDict because it is a very not overblown way to make Python dictionaries persistent. So you can do the quick data capture from anything thing that you've pulled data from. If you've pulled data from something, there's going to be some arguments, parameters, URL, what have you, but it's going to be unique, and that becomes your database key. If you have to pickle it, so be it. Your key can be a blob, a pickled Python tuple, or named tuple are two data formats that come to mind that make extremely useful composite primary keys and pickled dictionary keys under SqliteDict. Oh boy, this is such a fun way to work. I can't believe I wasn't primarily working this way for the past 10 years. I wish I was, but I was cobbling together different solutions, reading and writing directly into CSV files and Python pickles and shells. The shelve API comes to mind. Almost everything I'm talking about with SqliteDict, back-ending with SQLite, making dictionaries persistent, can also be done with the shelve API that's built on Pickle. Pickles and shelves can do the same thing, but the performance is terrible. You would not want to wait through stepping through, say, 1,000 response objects from 1,000, HTTPX gets of web pages. Grab the response object, drop it in SQLite through the SqliteDict API. Bam, now you got your raw data capture. One more transform to step through for each key in the database. You somehow or other get a list of dictionaries for each record. You drop that into a data frame optionally drop it into a data frame. You can keep it as a list of tuples, maybe not a list of dictionaries, but then you can use one of my tools that I'm developing under my new package that handles composite primary keys. See, what you need is not Pandas.toSQL, which, while is nice and which will let you pick a primary key column, it will not let you pick multiple for a composite primary key column. Yet when you're doing transforms from key value captures to row and column tabular data, you are, in my estimation, in my humble opinion, going to want a composite primary key 9 times out of 10. Nobody works this way. Everybody should. You look at your table, you say, what combination of tables defines uniqueness? What cannot have duplicates in it? And very often you get something like URL and keyword. For this URL and this keyword, here is the position you are coming up in search. Here is the number of impressions you had in the search engine. So pulling Google Search Console data, which, speaking of which, that's my project. If I were to stay up late tonight doing a project, it would be for every URL, pull my GSC keywords. So you can pull the metrics. You always get the metrics, which is impressions, clicks through ratio, and position. And you can get some other dimensions like platform and geography. But I rarely ask for the platform and geography because it explodes the number of rows that are coming back that you need to process. And in general terms, you want to know how good is this website, how good is this URL from this website doing on this keyword? Yeah, this URL, this keyword. And you get back the metrics. You can also give it just the URL and get back a list of keywords of n length up to the extent that Google Search Console has recorded it, but you can certainly get, say, the top 5 by descending by some one of those metrics like impressions or clicks, which is exactly what my late night project would be tonight, but it's going to get pushed into tomorrow. I've been pretty ambitious in cleaning up my package over the weekend, preparing it for general release in alpha or at best beta version. But it'll be another one of it'll replace Pipulate for a while, and then after a while it'll become the new Pipulate for sure. But I need to have it in kind of a separate namespace temporarily to do things that are not constrained by API compatibility restraints that I'm keeping on Pipulate today. Keep it working the way it was working so I don't break it for the handful of people that might actually be using it. But then I'm gonna break Pipulate and take all the work that I'm doing right now in ML SEO, roll it back into Pipulate because it's a better name, it has a better number of stars and everything. And is that bait and switch? It might be bait and switch. I gotta think about that. But it's such a good name and such a good domain, and I got it all. And if I have any difficulty getting anything else, I always have that to fall back on. Levinix and Pipulate, Levinix and Pipulate, Pipulate and Levinix, Levinix and Pipulate. I guess that's where I end this. I'm sure I'm over an hour now. What am I up to? Hour and 5 minutes. Well, anyone who follows these, well, thank you. Comment. Oh my goodness. I got some audience out there apparently. I do roll out content, and the content that I will guarantee you is different from anything else on the internet and on the YouTube. So, yay, tune in to me. I'll teach you a thing or two. I'll teach you how to earn a 6-figure salary without a college degree. You'll have to get a couple of years of experience. You might have to take some low-paying work to get the experience, but I'll teach you how to everything is custom and everything is automated. Everything is completely formulaic and everything is completely custom every time. Both things are true simultaneously. Everyone is your second most important client. You have nothing going on in your life more important than the work you're doing for your immediate bosses, other than that other thing you're working on, which is really the subject of your passion that enables you to do the work you're doing for your bosses. They have to know that about the free and open source community today. They have to know that many of us are driven by the ego kick it gets us by developing tools, putting those tools out there, and to see if those tools are useful to and embraced by other people. And then you get to become that kind of puppet master at the top of the GitHub repository, either accepting or rejecting pull requests, PR requests. And none of my projects have reached that point. There's been a few pull requests for Levinix and stuff to fix a few install scripts things, but for the most part, Levinix doesn't have install scripts. Let me take that back. Server build scripts. But it's little things here and there. So I've been so at the beginning of like things taking off in a big way, and then I let the steam, just the air come out of the sails. I'm the first to unbox the Raspberry Pi, or might as well be the first to have unboxed the Raspberry Pi. I get the surge, the million view videos. I could make A lead to B, lead to C, lead to a career on pandering to YouTube. But that's not the carpentry skills I want. It's not the satisfaction of the job that I want. I want to be doing the type of work that I'd like to be talking about on YouTube. I don't want to be a YouTuber. It's a little icky. I want to be a data master, or the other fields I was talking about. Stop me before I sub-reference again. Data master, data science, or data engineer. If you're not going to be an SEO, You are taking steps towards becoming what you could call a data master in sort of the tongue-in-cheek way that webmasters of yore did it. It's perfectly fine to do it, although honestly, you're not going to hold a candle to the machine learning systems, the dare I say AIs, who are going to be the real data masters, except you'll be a good data mechanic. You'll be able to get it, store it, transform it, and deliver it, and visualize it. Visualize and deliver. These are really good things. You're going to be a mechanic, and that's why that data engineer comes into the picture. Data pipelining is playing more and more a part in these things. I've been resisting it so long, and one of my coworkers about has me ready to embrace it, which is one of the reasons we hired them. I mean, there's another bigger, more important reason that has been sucking up a lot of his time, which is fine, but he's going to sort of corral our data consumption and reporting needs of our department. Oh, and it's great how we all have our own ad hoc tables. It's nothing ever like how it used to be, how, table ERD diagrams is such a big, important thing. You just start to treat, RDBMS tables, on some Postgres server somewhere in the cloud as generic key value, the same way you do key value, off the cuff without hesitating to create another key value database because it's all just key value pairs. You can just do RDBMS stuff that way. I'm so unused to that because I'm so used to the Microsoft SQL Server days, not in the cloud, where there was a lot of tender love and care, a lot of measured 10 times, cut once. You don't do things that change database structures, or you break things for everybody. But if you're doing things for your own personal apps that just happens to need to do RDBMS, relational database management system in the clouds, you got your own set of tables. They can even be under your own permission, so only you can read or write to them with your own apps. It's different days in the SQL world. It's different days in the RDBMS world than what I was accustomed to growing up in my old school boomer days of SQL Server and Microsoft IIS environments.